The session chair for this session would be Professor Vandana Bhattacharya. Professor Vandana Bhattacharya is a renowned computer scientist and professor with expertise in the field of computer science and engineering. She holds a PhD from Jawaharlal Nehru University, where she completed her doctoral research. Prior to that, she earned her MTech in computer science from JNU and a BTech in computer science and engineering from BIT Meshra. As an accomplished academic, Dr. Vandana Bhattacharya has a significant number of research publications in prestigious journals and conference proceedings. Her research work spans various areas including machine learning, deep learning, image processing, data analysis, software engineering, and healthcare applications. She has contributed to topics like disease prediction, brain signal analysis, image classification, software defect prediction, IoT applications in healthcare, and many more. Apart from her academic contributions, Professor Vandana Bhattacharya has been actively involved in research projects and has received funding from reputable organizations. She has also authored a book called Data Analysis Using Statistics and Probability with Our Language. I would now request ma'am to kindly take over the session as a session chair.
So, list of papers there is reading of the नहीं ये इसे यहीं पे ठीक है ना अब वो कर सकते हैं सर आपकी ये डिस्टर्ब हो जाएगा चेयर से कर दीजिए
The duration for each presentation is 10 minutes. I would like to invite the first paper presentation for today's Day 1 conference. The topic for this paper is Evolutionary Algorithms with Niching to Obtain Multiple Optima for ECG-Based Identification. Ma'am?
Good afternoon, everyone. Myself, Mamta Pandey. I am faculty over here in Department of Computer Science and as well as research scholar in Department of Computer Science from Mishra. And my topic is evolutionary algorithms with niching to obtain multiple optima for ECG-based identification. In this paper, I am going to present novel variants of three evolutionary algorithms: genetic algorithm, binary differential evolutionary algorithm, particle swarm optimization algorithm with niching to get multiple optima from multiple populations. And these algorithms has been applied to 71 fiducial ECG features. And the optimization criteria for the optimization is to maximize the accuracy of SVM classifier, at the same time minimizing the number of features in the subset. for identifying the person. So, a brief idea about evolutionary algorithms. They are inspired by the process of biological evolution, and they are used in recent problems to solve complex problems, and especially when the solution space is not much well defined. They are based on the principle of natural selection, genetics, and survival of fittest. I have listed 5 most popular evolutionary algorithms which are currently being used in the research areas. I am discussing the 3 only here, and these are applied on ECG. So ECG, it looks like this as shown in the graph, and we can see here the PQRST points. It's a periodic signal, and usually these are used for the medical diagnosis, but in recent research it has been used, many research are going on to that are proving it as a potential tool for the biometric tool. So here is an attempt to identify persons based on their ECG recordings. So because based on the peculiarity points, these are the features that has been calculated. Amplitude features, they are the difference between the amplitudes of the peculiarity points. For example, first one is Py. This is the difference. This is the amplitude of point P, and second one is PQ. This is the difference between the amplitude of point P and point Q. Similarly, the temporal features, these are the differences between the time instances of the points. The distance features, they are the geometric difference between the features. Similarly, slope is slope between the 2 points. Then angles that has been created in the heartbeat, and other some 14 miscellaneous features. Total there are 71. So with the 71 features, there will be 271 subsets, and we have to find a minimal subset that gives the maximum accuracy. So for this, we are first encoding it for applying the evolutionary algorithms. The encoding is like every subset is a string of 71 bits, and if a feature is present in the subset, then corresponding bit will be 1. If not present, then it will be 0. The simple encoding scheme, binary encoding scheme is over here. And then the next most important thing is objective function. There are 2 parts of the objective function. First one is 71 minus the length of x divided by 71. 71 is total number of features, and length of x means a subset x, if there, how many features are there. So it will be maximize the drop features, and same time the accuracy of SVM classification. So we are maximizing this combined objective function. First of all, genetic algorithm, there are 3 main operations that have to be done: selection, crossover, and mutation. All are in random way. Selection is random for the parents, and crossover, 2 parents go for crossover depending on the random number R for each bit of the child. If and there is a crossover rate CR predefined for the program, and depending on that, if R is less than, then it bit will be from the parent 1, otherwise bit will be from the parent 2 in the child 1, and reverse in the child 2. And if it's greater than, then child 1 will be from the parent 2 bit, and for child 2 it will be parent 1. And after crossover, after random number of iterations, there will be mutation. Mutation is actually applied for the diversity, so that it should not be converged to a local optimum. So mutation is, of course, it is also random. R is generated randomly. As if it's less than mutation rate, then bits will be reverted. Binary differential evolution is second. Here is also mutation and crossover operations, but difference is that every individual in the initial set of solutions is mutated. And this is a formula for binary. Actually, this differential evaluation is originally developed for the real numbers, but here we are going to apply for the binary values, binary string. So there are some variations over here. For example, here f is scaling factor, that is the 71 ones in a row, and s is best solution so far recovered, and R1 and R2 are two different solutions from the population, and from there the mutated individual has been derived. And then crossover is performed between the individual and its mutation mutant. That's also random depending on the random value and crossover rate as shown in the equation 5. Particles from
Warning for you. How many more minutes? 2 minutes.
10 minutes again.
2 minutes more. Yeah.
Okay. Then particles are the velocity and positions are there. Positions are actually the solution here according to the 6 and 7. I will go fast. Niching is after applying the algorithm, these are the subsets that we have achieved from the all other three algorithms. Niching is actually is for multiple optima. If we apply normal on the normal data set, then it will be give the single optima. But if we have a multiple subset that giving the good accuracy or optimizing the constraints that we have, then normally applying the evolution will not give the result. I was facing a problem that on each iteration I was getting a different results. So I went with the multiple populations in parallel and applied those algorithms in each and every population. My thing was ki in every iteration, if first I have trained the classifier with the all 71 features, and I got the accuracy of 0.98. That I held is as the threshold. And whenever a optima gets a accuracy of 0.98 or more, that is the optimum. I was assuming and reinitializing the populations again for applying the evolutionary algorithms. That way, I got 100 unique optimal subsets for each algorithms. And when I analyzed what are the best accuracies, I got 0.99, and these are the 6 subsets. All gives the accuracy of same 0.99. And these are the in this from binary differential evaluation, I got the minimal subset of 24 features with the maximum accuracy of 11. So main thing is if we can achieve a better result with the less number of calculations, is always better. We can add 5% with the 71 features, but if we can do the same thing with only 24 features after activity, then also here we are slightly achieve betterment in the accuracy also. Thank you.
Okay. Thank you, Mrs. Mamta. You gave a good presentation. I have one question in your optimizing function.
Yes.
What are you writing about lenx? Go to that slide.
Yes, ma'am. Length means length of the subsets.
अब उसमें जाइए.
Yes,
हाँ
ma'am.
ये. What are you doing here? पहला वाला जो आपका है.
Okay, ma'am. Length is number of features in the subset.
Okay,
So,
number of ones in
for
the
example,
subset.
I have 24 features, then x will be 24.
So you want to reduce that.
Reduce that. So 71 minus 24 is number of features that has been drawn. So I am maximizing that.
So, ma'am, what is the significance of the numbers?
Because minimize, sir.
नहीं आप बोलिए.
What is the significance of the number 71? Means why is it a constant or?
No, sir. It's not a constant. I have in my research have used 71. Actually, there are many researchers have been gone in on these things. Some people have used 26 features, some has used 72, some has used some other methods are there. So I got to select only 71 for now.
If number of subsets increase,
Yes.
then it might be 71 to 73,
Yeah, yes, sir.
74,
Yes, sir.
75.
How many features are you are going to use?
Because in one slides you have total number of features.
Yes.
71.
Yes,
So
these are the features that I am using in my.
total 71.
Yes.
It might increase.
Yes, sir. It may increase, may decrease. That depends on the domain also. If we are going to apply this on other domain, then number of features may change. 71 for this particular case.
So only accuracy you need, you don't need precision, recall or anything. Other parameters are not required to judge the goodness of your result.
That will be significant, ma'am. I think F1 score is better, but just for optimization, I choose accuracy.
That's all.
Thank you.
Any other questions? आगे आगे गया था आगे yeah thank you.
I now invite the second paper for today's conference, Diabetes Prediction Using Data Mining Techniques. Prediction of diabetes using data mining. This is the lecture. Yes, from the desktop. It's on the desktop.
You are the only author of this paper.
No. There are one
सारे नाम डालने चाहिए. और कौन है आपके साथ इसमें?
Ma'am Aditya Kumar Singh, one my batch, and Sanjay sir, and one more Suman Kumari.
So you should write all the names. Okay, in the presentation slide.
Good afternoon, one and all present here. Myself Jyoti Kumari, and here I am going to present on the topic prediction of diabetes using data mining technique. So before we jump into our presentation, let us first know what the diabetes is. So diabetes is a condition where the blood sugar level increases. There are many forms of diabetes, but the diabetes type 2 are the most common one, and it is caused due to the decrease in the insulin level. People suffering with diabetes have a higher risk of suffering from many diseases like heart disease, circulatory disease, and kidney failure. So now let's jump into our presentation. So we have our introduction. Diabetes is as we discussed, diabetes is a chronic metabolic disorder characterized by elevated blood sugar level. It is a major public health concern affecting millions of people worldwide. Early detection and management of diabetes are crucial for preventing complications. So now the questions arises, why data mining? So data mining technique can extract hidden patterns and relationship from the larger data set. Prediction model can be used for early detection and prevention and personalized treatment planning. So now we have our next slide, workflow of our model. First we will take our diabetes data set, then we will perform the learning of data, which includes how many attributes are there and which one is the targeted attribute. Then we will perform the data pre-processing. So the real world data may consist of noise and unused data. So we will clean the data. Then we will perform the training and testing of the data. Then training of the data includes the our models like KNN, logistic regression, and random forest, decision tree, support vector machine, and any more, which will train the data. These include the classifier training, and then we will perform the testing of our data. Then we will check the model evaluation and check has reached the desired accuracy or not. Then we will predict our data. So moving to the material we use. Here we use the PIMA Indian diabetes dataset sourced from UCI repository. There are mainly 9 attributes present in the dataset that are listed below: number of time pregnant, plasma glucose concentration, blood pressure, triceps skin fold thickness, 2-hour serum insulin, body mass index, diabetes pedigree function, age, outcome, and here outcome is the targeted attribute. So the algorithm which used are random forest, decision tree, KNN, K nearest neighbor, logistic regression, ANN, artificial neural network, support vector machine. So what the decision tree? It is a tree-like structure that represents series of decision and their outcome. Here the node signifies the decision and the leaf node signifies the outcome of the model. So now we move into our random forest. It is an ensemble method. Means it combines different predictive models. Here we will combine different model of a decision tree. It uses 2 techniques to reduce overfitting and improve generalizability, bagging, and feature randomness. So moving to our next slide, K nearest neighbor. It is a parametric model, means it does not make any assumption. Instead, it simply learns from data and predicts the value. It is also an instance-based, means classify new data on the basis of existing data. So now we have our logistic regression. It is a statistical method used for binary outcome, predict whether instance belong to one category or not. Not only predicts the data, it converts the independent value in the expression of probability, that is 0 or 1, in the basis of the dependent variable. Here we have mentioned, I have mentioned, also estimate the probability that the instance belongs to each class. Here we will use the sigmoid function to convert our probability into the value of 0 and 1. Now moving into the next artificial neural network. It is inspired by the structure and function of the human brain. It learns the data through a process called learning and adjusts the connection between neurons and minimize the error in the prediction. Here we in the figure we can see there is input layer, hidden layer, and the output layer. So we have our next support vector machine. It is used for the classification task, means they predict the category to which an instance belongs. It founds a hyperplane, a decision boundary that separates data point of different classes. So as we know, there are many researchers who already wrote the paper on predicting the diabetes. So in our paper, the main difference is we uses a bootstrapping sampling technique to enhance our accuracy rate. Bootstrapping sampling is a resampling technique which is used to improve accuracy and reliability of estimates. It involves creating multiple random samples called bootstrap replicates from a single original sample, which provide more robust estimate of the population. So what are the future scope? In this study, we mainly focus on diabetes disease. It can be further processed, which can be applied to another disease. This study utilizes a relatively small amount of sample data. Our model has the potential to be applied on the larger data set also. So now conclusion, data mining technique has the potential to revolutionize diabetes prediction. Our proposed methods yielded an impressive accuracy of 90.4% using random forest classifier, surpassing the performance of other algorithms examined in this study. So we conclude here. Thank you. If any questions.
So you know what is a random forest?
Yes, ma'am.
What is the difference between random forest and decision tree?
मैम इन रैंडम फॉरेस्ट ये इंसेम्बल टेक्निक को यूज़ करता है. इसमें अलग अलग मॉडल्स को हम लोग कंबाइन करके एक प्रिडिक्शन वैल्यू को प्रिडिक्ट करते हैं, जिसमें हम लोग कोई सा भी मॉडल को कंबाइन कर
किसी भी
सकते हैं.
ensemble में डिफरेंट मॉडल्स को यूज करते हैं. रैंडम फॉरेस्ट में कौन से मॉडल्स को करते हैं?
डिसीजन ट्री को हम लोग अलग अलग डिसीजन ट्री को कंबाइन करके उसका वैल्यू को मीन निकालते हैं कि.
So how did you write the code for this Python library?
यस मैम, पाइथन लाइब्रेरी. यस मैम.
उसमें कितनी डिसीजन ट्री जनरेट हुई थी देखा था आपने? उसके ना उसमें जाके देखिए डिफॉल्ट में. आपने बहुत अच्छा काम किया. बीइंग अ BCA स्टूडेंट, you have actually executed the code, which is very good, and you explained it also very well with confidence. I must say, इतना ताली मिलना चाहिए. इतना कॉन्फिडेंस से आपने प्रेजेंट किया, बहुत अच्छे से किया. तो you should go and check the default values. 100 is probably the default value, मुझे जितना याद आ रहा है. But that is one thing which you should know जब आप कोई प्रोग्राम. ठीक है ना? तो you have interest in this kind of
Yes,
research. Thank you. Good from my side. बाकी लोग कोई ठीक. Okay. ममता कहाँ है?
आपका भी अच्छा था.
Thank you. We should clap for each presenter.
yes.
That is very important.
So now we'll proceed with the third paper for this conference. The paper title for this presentation is A Comparative Study on Machine Learning Approaches.
Third, fourth one.
Okay. So we do not have this participant. The next paper for today is Predicting Stress Levels Using Sequence Modeling in Deep Learning.
ये आपका था. थर्ड वाली आपके स्कॉलर कल आएगी.
Good afternoon, everyone. Myself Shashikala, and topic for my presentation is stress prediction levels using sequence modeling in deep learning. So, here are the agendas of the presentation that we're going through. Now, introduction. First, what is stress is. Every one of us go through stress in our daily life. It could be the state of worry or the tension or the mental tension that we go through. But how we go through it is also in our nature, that how we come through the stress. Now, what is deep learning? Deep learning is basically a subset of the machine learning, which involves the artificial or the neural network that train the data and that indicates that train the data, and through which we can get the program without the more use of program. Sorry, we train the data and we get to the data without the help of more program. We basically train the data in this. So why we are using the deep learning and not the traditional methods? Basically, complex nature of the stress pattern. Stress patterns often struggle in capturing indicating the non-linear pattern associated with stress or the future representation. Deep learning algorithm can automatically learn hierarchical representations, extracting features that might challenge our traditional methods. Big data challenges. Deep learning excels in handling large data. Temporal dynamics. Stress is often dynamic in nature, so influenced by temporal factors. Now, the fundamental procedure of the stress. So basically, we will use the actigraph watch, which has the sensor device implemented in it, through which we will collect the data, and then we will use the models like RNN, LSTM, and GRU to predict the data, to know that whether the stress is positive or negative. Now, here are the algorithms that we're going to understand that recurrent neural network. long short-term memory, and gated recurrent unit. Now first, recurrent neural network. Recurrent neural network is basically it is a form of the connection which forms the cycle. In this, in which through cycle, the data of the input of the previous input can be stored in it, which can be used for the future uses. The problem with this is that it has the vanishing gradient issue. To overcome that issue, we use the more improvised version of the recurrent neural network, that is LSTM. So LSTM is basically the long short-term memory. It had basic of 3 gates and 1 state, that is forgate gate, input gate and output gate, and 1 cell state. So basically cell state, it is a internal memory where we store the data. It has the internal memory where we store the data of the information, of the large set of the information. In forget gate, whatever the data we don't want to get it, that we want to forget or delete, for that we use forget gate. For input gate, whatever we want to input, considering the input, we use the input gate. In output gate, we use the state to delete the data. Now third one is GRU, gated recurrent unit. It is the more improved version of the LSTM in the sense that in this the update gate has the comprised version of the input gate and the forget gate of the LSTM. So it uses less parameters, and because of the less parameters, it have less complexity. So using this, we can more complex data in this we can predict with this. So coming to the data set, we have the basically 55 persons data set, in which 23 patients were diagnosed with healthy, and 23 patients were diagnosed with patients, and 32 patients were healthy. We used the Montejarmi Adresker depression rating scale, which says that if the rating scale value is above 60, then the person is depressed, and if it is less than 10, then the person is not depressed. Now the experiment, here the initial hardware that we have used for the experiment, which are the Windows 10 and the Intel Core, and for the code implementation we have used Python 3 with the code base TensorFlow and Keras API. So confusion matrix, we have used confusion matrix to know which model is more better for the predicting stress. Now this is the result. In result, we can clearly see that the accuracy of the GRU is highest with the 81%, whereas the support vector machines recall value and F1 score is also good. With that, random forest value of the precision value is also great. So through the figure 6, 7, 8, we can see that the training data value is getting low, but the testing data is getting high. That's the difference between these two sets. You can get the issue of the overfitting. So to get this issue overfitting, we have to take more amount of data. We have to collect more data, so we can go through the problem of the overfitting. In conclusion, I would like to conclude, we can use more, there are more techniques to we can predict the stress, like ID convert, etc. There are the update versions of the RNN, but we can, through the experiment, we learned that the GRU is the better model for this predicting stress. Here are the references that we have used. Thank you.
Can you repeat slide number 16 again?
Should I repeat it? Yeah.
So you are an MC student.
Yes, ma'am.
So you have done good work. This data which you have used, this is collected from somewhere or your primary data collection?
Ma'am, it's from Intel.
Internal. You have taken data. So you need to take more data.
Yes.
To get better.
Yes,
क्योंकि आपका model is more complex, data is less.
yes, ma'am.
So either get more data or reduce the complexity of the model.
Yes.
तो ठीक है, आपका अच्छा काम. were in the second year, first year. So you were interested in research? PhD? ओके तो जॉब के बाद हाँ ठीक है.
The next paper for today would be SRS, Gender-Based Heart Disease Prediction using Stratified Random Sampling Approach.
This is online. Offline है. अच्छा अच्छा. Okay. और इसमें ऑनलाइन था तो मुझे 1009.
Yeah.
ये तो विजय लक्ष्मी.
This is the latest one.
Full screen. Three
This is
dots.
in the form of a PDF.
Okay, fine. Three dots. Full screen. See here. Three dots.
उधर में दिख रहा है.
Three dots.
Should I give the pen drive?
No, okay.
No, not. Okay. Very good afternoon to all the respected dignitaries and my colleagues. I myself Vijay Lakshmi, working as a faculty in the PIT Nagpur and also research scholar. So my today's presentation is on gender-based heart disease prediction using stratified random sampling approach under the guidance of Dr. Jayapal and Spriti Kandia. So the outline of my study is starting with the motivation. So in the cardiovascular diseases have a considerable influence on the global health. So and the observation of various risk factors and outcomes motivates our study. In going to the introduction part, the main objective of our study is to identify the gender-specific cardiovascular risk factors. This study applies logistic regression and stratified sampling approach to the prevalent data set. And it compares the performance of the model across the gender divisions and attempts to determine how the clinical attributes differ between men and the women. Through analysis. Introduction. In this introduction, cardiovascular diseases are significant for the global health concern, causing the substantial mortality in the worldwide. Despite of the medical advancements of the CVT, prevalence of the cardiovascular diseases remains high, and the prompting further investigation is required through analysis of the risk factors into their underlying risk factors. Gender influence on cardiovascular disease illness development, progression and outcomes has gained increased attention recently. Data-driven techniques and the machine learning are employed, establish connection between the variables and inform the medical decision making. The prevalent heart disease dataset is used for this because of its extensive clinical and non-clinical attributes forms the basis of this study, contributing the comprehensive cardiovascular health insights. This research aims to enhance the understanding of diverse risk factors affecting the heart disease genders using the UCI library or prevalent dataset. The model accuracy improves in the CVD diagnostics in early heart disease detection in both males and females, enabling the timely preventive measures. The potential outcome involves the development of gender-specific diagnosis therapies, refining the healthcare policies, standardizing care, and enhance the outcomes. Enable the outcomes. This is the flow of my proposed research approach. And this proposed research approach, the flow starts with the patient data set is taken from the prevalent data set. On that, stratified sampling approach is applied and divided the data set into two different strata, female strata and the male strata. After that, feature selection techniques are employed on that to get the best features, and then classifier is logistic regression classifier is implemented on that to get the binary output. Because to get the output of this classifier, so we use the logistic regression in this. Next,
proposed research approach, introduction of stratified random sampling to partition the data sets based on the patient gender. By recognizing and quantifying the variation of risk factors between the genders is a novel contribution which adds a new dimension to the risk assessment techniques by considering the gender specific factors. Structured approach of our research. So the phase 1 is about segmentation of the data into male and female data set, which inside phase 2 involves the pre-processing steps such as handling the missing values and selecting the essential features through features ranking voting. And the phase 3 about selection of suitable classifier models for each gender group. And phase 4 utilizes the proposed classifier for classification task, leading to the improved accuracy, sensitivity, and the specificity. Stratified random sampling approach overview. In this stratified sampling, we stratified the dataset into male and female groups using the stratified random sampling, which ensures the proportional representation of gender within the dataset to avoid the imbalance. Sample size breakdown is 207 instances for male data and 96 for the female data. And here the feature selection techniques what we have applied is chi-square test. So chi-square test is calculated in between the observed and the expected frequencies of the data and the variable. So chi-square statistics determines the deviation between the observed and expected frequencies, and then under the assumption of the independence. So rejecting the null hypothesis indicates the dependence between the features. And then next approach is mutual information gain approach. In this mutual information gain approach, high mutual information indicates the strong relationship between the variables. And it calculates the ratio between mutual information between the two variables and then entropy. So if the entropy is less, we can expect the more information and the variables are more dependent. Next, we apply the logistic regression classifier. It uses a categorical dependent variable producing the binary outcomes of 0 or 1 and employs the sigmoid function, transforming the real number between the 0 and 1 probabilities into probabilities. So P of x represents the sigmoid function. Here x represents the input of the probability function, and the P of x signifies the probability estimation function yielding the value within the range of 0 and 1, and it classifies cardiac disease as 1 as present, 0 for absent based on the algorithm predictions. Next, these are the features which have been taken from the prevalent data set. One is age, gender, chest pain, and resting blood pressure, cholesterol, fasting blood sugar, and resting ECG, and then maximum heart rate, and exercise-induced anemia, and the volt peak, slope, and the number of blood vessels, and the stress levels, and the output. Next, in the experimental framework, under the experimental framework, we started with the data pre-processing. The proportional stratified sampling ensures the sample size and the representation or the representative of the proportions. Male stratum is 207 instances and female stratum is 96 with the 14 attributes. Feature scaling is through standard scalar method to achieve the normalization standards. And then we applied under the implementation, we implemented two techniques, feature selection techniques. One is which is above mentioned, chi-square, and the information gain. After that, application of logistic regression model by splitting the data set into training and the testing. And then experimental and the performance and metrics also we employed. So the performance metrics we employed are precision, recall, F measure, specificity, and accuracy. But out of those measures, we have considered these four things: accuracy, precision, sensitivity, and the specificity of the data. Next, the attribute ranking for the female string. So these are the attribute rankings for the female data. So one is chi-square distribution technique and one is for information gain technique. Here the resting blood pressure is holding the highest rank under the chi-square technique. Under the information gain technique, stress levels.
Warning.
stress levels are taking the yes. So I'll go to analysis. Feature ranking analysis. So here, according to the chi-square analysis, maximum heart rate and cholesterol are more significant for men, and resting blood pressure and the stress levels are more notable for women. This suggested the varying in the certain attributes based on the gender predictive outcomes. In the mutual information gain ranking demonstrate the significance of resting ECG for men and emphasizes on stress levels and the age for women. These variations guide the predictive model status to each gender group. Then lower importance features. So always fasting blood sugar is in both the cases, in chi-square and in the technique of the information gain, and in both the strata also, even for the males also, for the females also, it will show low importance. And the common variables are the importance of the specific variables such as the old peak and chest pain are common variables for both the males and the female strata, that these characteristics are the reliable indicators for both the genders. And then significant predictors independent of the gender. So here, certain features remains influential predictors regardless of the gender. So here, the rankings from the chi-square and mutual information gain illustrate the differential value of the features in male and female strata, which helps in the selection and the model construction for gender-specific predictions. So, based on this, we concluded that top 10 best features out of these two techniques are, we conducted the analysis based on those features, top 10 features. Next, classifying performance. The logistic regression used on this after selecting the features, and then this is the table which shows the performance analysis of a model for different feature selection techniques and with all attributes. So, with chi-square distribution technique, the female strata classifier is showing 100% accuracy, but male data classifier is showing 85%. But using the mutual information gain features, female data set is showing the accuracy of 95% and the male data set is 85%. With all attributes, 95% it is showing, and male data set is showing less than the previous techniques. This is our graphical representation. Here there is a change in the specificity of specificity of the mutual information gain, and with all the attributes, the specificity is changing over there, and here sensitivity is changing. Next, analysis. So according to the feature ranking and according to the classifier, and then the analysis is chi-square approach. Female classifier approaches flawless with 100%, achieving flawless accuracy with 100% sensitivity, specificity and precision with 0% error. But same approach in the male performance, it shows very lower accuracy with 85.71% and decreased sensitivity comparative with the females. So next, mutual information gain is yielding comparable findings for accuracy, sensitivity, specificity and precision, demonstrate with the balanced performance over. Next, gender comparison. Because female exhibit the stronger performance, 95% when all the factors have considered with all attributes. So this comparison with all attributes, and then the accuracy and the precision of males with all attributes are significant and lower compared to the females. Factors influencing performance, because the author rejected the paper on this point. So here the factors influencing the performance. Beyond the sample size, 14 features are equally relevant and representative for both the genders. Certain features hold more significance in females than males, impact the overall model appearance. Next, coming to the conclusion part, research introduced the techniques for gender-based cardiac patient diagnosis. Implementation of feature selection approaches significantly improve accuracy and model simplicity. Female classifier achieved flawless scores across all criteria, which proved to be the best attribute selection techniques. Next, mutual information gain showcase the comparable performance for both the things. Chi-square making it as a reliable option for both the genders. Chi-square is highly recommended for the female classifier. MIG is close to the second due to its outstanding performance. Chi-square and MIG showed similar performance for males, suggested the use of all attributes with selection as an alternative. Future research. For the further research, we have extended this analysis to take into account the intersection between gender and the other demographic characteristics and examine how these intersections impact the classifier performance. not only the logistic regression, we can use the other algorithms also, because here I use, this is statistical machine learning algorithm. Logistic regression is the statistical machine learning algorithm. That is the reason why I used it. So later I can compare with all the other algorithms and I can explore my
But 100% accuracy is always something to be
yes,
questioned.
yes, ma'am. It's question. Yeah, it's question.
ठीक है, good presentation.
Thank you.
हो गया ना? Session is over. और certificate आप लोगों को दे दो. आप लोग ना इसका टेबल का फॉर प्रेजेंटेशन आई थिंक यू शुड हैव द टेबल ऑन दैट साइड बिकॉज आई शुड नॉट बी बैकिंग द सिटिंग इन द बैक टुवर्ड्स द ऑडियंस
नहीं हम लोग इसीलिए यहाँ पे रखे थे
नहीं
यहाँ रखे थे
तो वहाँ तो इसके पीछे हो जाएगा ना वो भी
ऑनलाइन
ऑनलाइन
ऑनलाइन के लिए अगर
हाँ ऑनलाइन के लिए वहाँ हो जाएगा हाँ ऑनलाइन
इसलिए हम
तो ऑफलाइन के लिए आप इधर का ऐसे
Work
कुछ
कर
कर सकते हैं हाँ अच्छा आपका तो मिक्स्ड मोड है ना
हाँ
एक्चुअली कौन सर्टिफिकेट नाम कौन अजय आप यहाँ पे इधर तो खाली है जगह
उन लोगों को नाम बोल रहे हो ना इसका किसका बोले पहला नाम नहीं है ना ममता पांडे तो फर्स्ट पेपर इस ममता पांडे अपना मैम फोटो फोटो फोटो
फोटो कौन ले रहा है
खाली चलिए ठीक आलोकित कर रहा है ज्योति कुमारी शशिकला मिसेस विजयलक्ष्मी
आप पीछे इसको ओके
With this, we conclude the first session of today's conference. I would like to extend my heartfelt gratitude to our esteemed session chair. Ma'am, your expertise in the field of healthcare and medical applications of machine intelligence have gratefully guided the session with finesse. Thank you, ma'am. I request all the participants and conference members to kindly proceed